Welcome back. So before we get any further into circuit analysis, we're going to talk about Ohm's law. And Ohm's law are very, very important. The Ohm's law, we can say that those are the building blocks of the whole circuit analysis. And not just circuit analysis are important for many, many applications. So let's start with Ohm's law are three. So Ohm's basically stated three laws. And the first law, I'm going to write I'm just going to write Ohm's law. So the first law states that V, so the voltage, is equal to IR. So the voltage is equal to the current times the resistance. Okay. From the first law, you can basically get all the other formulas. So if you want I in terms of V and R, you can get I. If you want R in terms of V and I, you can get R. A way to memorize this is the triangle. So we put V on the top, I on the bottom, and R on the bottom. Those form a triangle. So if you want V, I'm going to cover V and say, okay, VI is I times R. If you want I, you can say, okay, I is V over R. I is V over R. If you want R, you can say, okay, R is V over I. So those three are, the direct and inverse formulas for Ohm's first law. Now the second law, and this is very important. Well, I can also offer you an example of this. If you have a voltage source, like this one, I'm gonna put plus and a minus here. Oh, I generally use blue for circuits. Yeah, my bad. So if you have a power source here, a voltage source in particular, like a battery, and you have, I don't know, like you have a resistance, and this is just gonna be your circuit. It's gonna be my resistance R. You can basically say, okay, I know that I don't know, like the resistance is 2 ohms, and the voltage source is, like we said, is a battery, so it's going to be 12 volt. So you can say, okay, fair enough. I want to find the current. So the current is going to be given by, cover the current, is V over R. V over R. So write I is V over R. So I is basically 12 over 2. So what is 12 over 2? Yeah, I heard that right. It's 6. So you can say that I is equal to 6 amps. So nothing fancy here. If they give you the current, you can find the voltage and so on and so forth. So this is Ohm's first law. Now the second law, Ohm's second law is also very important, because we'll be talking about resistors, but we haven't defined what resistance is. We'll be talking about all the circuit elements, like resistors, power supply, inductances, and capacitors, and diodes, and so on. But we haven't defined anything. Like we didn't write any formulas for them, because I did introduce Ohm's law first. So for instance, if you gotta define we know what a resistance is, okay? So this is a resistance, but we don't know what so we basically know what the circuit element, a resistor, is, but we don't know what the resistance is. We know that the resistance is something that opposes the flow of current. And we have defined the flow of current as electron flowing. And we know that 1 ampere is basically 1 coulomb flowing in 1 second. But what is resistance? Well, we can actually define the resistance R as ρ times L over S, where R is the resistance, ρ is a coefficient which is basically a scalar, and it's different from an element to the other. So it really matters on which element you're gonna use for your for making it, for using it as a conductor. L is the length of the resistor, and S is the area. So in other words, if you have, let's say that we're gonna look inside this resistor here, and we're gonna have something. Not gonna write, this is not accurate as a drawing, but it doesn't matter. So if we have a longer resistor, so this one gets longer and longer, then the resistance is going to increase. So it makes sense. You get this one, you make current flow through these, you make it longer, then they're going to have, charges are going to have to go from here to here, and it's going to take longer for them to reach the other end. So the resistance is going to increase. But S is also the basically the area of this resistor. So yeah, you can argue that if you make it longer, then the resistance is gonna increase. But if at the same time you don't just make it longer, but you also increase the area, so you make it's from thinner and short, you make it long, but you also increase the area, then nothing is going to change, because the area, the denominator is going to, well, the length, the numerator is going to be, magnified by the area at the denominator. We write as a surface, but it's actually the area. So at the same time, if you just keep it like at the same length, but you increase on the other end the area, so same length, bigger area, then the resistance is gonna be less compared to the other case. So it basically makes sense. It's pretty straightforward. Now, another thing to think about is Ohm's third law. So Ohm's third law basically states that, and we're going to use it a lot, we're going to use all of them a lot, in particular the first and the third. So Ohm's third law says that the power is going to be equal to I squared times R. So the power dissipated by a certain element in the circuit is going to be equal to the current squared times the resistance. So, for instance, if you want to find out the power dissipated by, I don't know, well, from this resistor here, you can basically say, okay, we have found the the total I of the circuit, which is 6 amps. You can say, okay, 6 times 6 times the value of this resistance. So in this case, will be the power will be I squared times R. So the power will be 6 squared times 2. So the power in total is going to be 6 times 6, which is 36, times 2, which is 72. So 72 watts. So basically, from this power supply, this resistor here is gonna dissipate 72 watts. And you can actually see that the power dissipated here is basically something that is gonna be dissipated in terms of E heat, because it's just a resistance. And if you wanna be if you want to feel comfortable with those values, you can say that well, don't write it. If you're writing those things down, it's fine. Don't write down the thing that I'm gonna tell you, not because they're not accurate, but because they're, you know, just for personal knowledge. You're not gonna use what I'm gonna write for circuit analysis, but well, I'm just not gonna write. But the toothbrush, it's the electric toothbrush is 2 to 4 watts. TV is about 100 watts. The plates that you have in the plates in which you use to cook in your kitchen, probably 1000 watts. The boiler is about 1200 watts. Computer really depends. But computer like not a tablet, like a laptop, about 140 watts. Desktop, more probably. Well, it really depends. They go from 350 to up to 1000 and more watts. It really depends from the components that you have, which GPU you have, and so on. And so on and so forth. Even the human body actually produces well, you can actually define the power as in joules in terms of watts, but watts are just joule per second. And this, as I said, in resistance, this is the power dissipated also in terms of heat. So if you just write those things in terms of W, so joules per second, it makes sense. Joules per second is something that you measure in terms of heat. And you may be wondering if you can relate this to the human body. And yes, you can. The human body, about 100 watts. So basically 100 joules per second. But of course, it doesn't light up like a light bulb, because it's a human body, so it has a lot of it basically has a very, very large surface. So you don't light up like a light bulb, but you produce infrared radiation, and this is very noticeable. You hug someone, you you can feel the heat of her body. So if you hug a girl, you can basically, you're not just hugging her, you can feel the heat that you are exchanging with her, and you are basically going to exchange the heat at about 100 joules per second. While if you're alone and you're hugging a blanket, for instance, you're just going to exchange the heat at about 50 joules per second. So that's pretty much it. I just wanted to tell you, because they're not going to be useful in circuit analysis, because we're gonna talk about circuit in this way and so on. But you can actually wrap your mind around those things and say, oh well, okay, now if I go to, I don't know, buy a new boiler, I know that 1200 watts are just joules per second, and they come from Ohm's third law. So yeah, I know what you're talking about. So yeah, if you see something into, when they say everything like the voltage, the watts, and so on, then you know what they're talking about. So yeah, that's pretty much it for Ohm's law, and see you next time.